All right, welcome back. Actually, I'm going to do this. Pause. All right, that might help. Okay, so problem number 4 here. Okay, let's see what we got. We have got. Yes, okay. So consider the parametric curves and finding the arc length from those parametric curves. Okay, so let's see here. This is definitely, parametric curves, area under a parametric curve, area within a parametric curve. Same thing with the polar stuff. If there's a question on the final that deals with any of that, putting the formulas for how to find the area, right? That finding the surface area of revolution, that's not negotiable as a formula. I'm putting it on the exam. Like, you will get the formula for the surface area, because at any time in my life when I've had to know that, I've had a chance to go look that up. So if there is one we have to do that, it's going to be there. Now, arc length, I've always kind of had a knack for, so I didn't have to really worry about that one. I didn't have to memorize it because it's just Pythagorean's theorem. However, if one of you say, you know what, I'm really going to need that one, I'm not going to begrudge you. It's not something I would volunteer to put on there, but if you guys really need it, I will put it on there for you. And I'm not going to ask questions or belittle you for asking. Okay, it's just not worth that. Actually, I might just put it on anyway. Okay, so we have to find the arc length here between t is equal to 0 and t is equal to 2. I don't believe this problem has us graph this thing. No, it doesn't. So if that's something, you can do this on your calculator, but again, I would need to go look it up again, how to do that. Okay, but your TI 83, 84 calculators will go through and graph these things for us. But pretty much the idea here is you pick your X's and your Y's, you set your T up, okay? And see, this 3/2 here is what's really doing it for me, because you have 2t plus 1. I'm like, from 0 to 2, huh? So we could put in a 0 and see what that does, and we'll get 1/3 raised to the 3/2 of, 1 raised to the 3/2. But then we got to be real careful about picking this so that we get nice numbers. Okay, so if they were nicer numbers, graphing it might be an option, but this is not a nice option to graph. Okay, not on a final exam. Okay, so to figure out arc length, right? Arc length is from A to B, right? Of the square root, and this is dx by dt squared plus dy by dt squared all times dt, right? Remembering, right, if we were trying to figure out the arc length, we would try to figure out, we would approximate this here, right? And that's our arc length. That's our little piece of arc length. And here's our dx squared, and here's our, I'm sorry, not squared, there's our dx. There we go. There's our dx. There's our dy. Okay, and we're just going to make this into a triangle and say this is dx squared plus dy squared, square root, that is equal to ds. Okay, that's how we got this. And then it's dx by dt. Okay, and then again, if you don't have parametric equations, you usually deal with this kind of a problem. But we either divide by dx and put a dx out here, or divide by dy and put a dy out here. Okay, so that's the other things that can happen. Okay, so in this case, we have a parametric equation. So we have to figure out what's the derivative of x of t, right? What is dx by dt? And again, not a terrible derivative, right? 1/2 t squared, that's just going to be t, right? And then dy by dt, and I know it's been a while since you guys had to do derivatives, but this is 3/2 times 1/3, right? 2t plus 1. The 3/2 drops down by 1, so we get 1/2 times chain rule 2. Okay, so all of this stuff, right? This is just 2t plus 1 raised to the 1/2. This is my dy by dt, and then dx by dt, right, is just t. Now, with our formula here, we're going to have to square them. So why don't we just do that right now? So dx by dt squared is equal to t squared. Dy by dt, so it's a y, squared is equal to 2t plus 1, because that's going to take that off. Okay, so let's go ahead and integrate this. So we have from 0 to 2, square root t squared plus, that's my dx by dt, 2t plus 1. Okay, let me give you a small hint for when you're taking this exam. I really like QT little, t plus 1 squares. I really like it when these things kind of combine and you get this really kind of neat substitution that can happen, or this, you can factor them and then you end up with something like this, because I really don't want this to be a terrible problem. I have a very fond recollection of doing all of these, and I want you to have a fond recollection of doing these. So this was just t plus 1, right, from 0 to 2. Normally we use plus or minus, but t is positive, this is positive, okay, dt. So if you don't see or get to one of these cutesy little things like this where they just kind of, everything magically kind of works itself out, check your arithmetic, all right, then tell me to check mine. But I try to go through and make sure that this kind of a thing is going to happen. So if you're not seeing something like this, check to make sure you finished your chain rule, right? Check to make sure you squared them right. Check for, check all the little pieces you have to check. Because I try to rate these problems where something like this should happen. Okay, maybe not exactly, but you should get like a sine squared plus cosine squared kind of a thing. Okay. All right, so here we go. We have to integrate this. So this is going to be t squared over 2 plus t. We're going from 0 to 2. Okay. If I plug in 0, we get 0. So all we have to do is plug in 2 squared over 2 plus 2. So that's 4 over 2 plus 2. And 4 over 2 is 2, so 2 plus 2 is equal to 4. And you're done. Okay, so like I said, you might end up with like a pi or something like that, but if you don't see some kind of a, oh, if I added them together, then we're going to be able to recombobulate them, factor, and then get a squared, so cancel the square root, and then you're good. You've got a nice clean integral to deal with. Check all the little details up to that point, because that should have happened. Okay, so I'm going to stop here and go ahead and post this for us.